Welcome everybody to lesson 2 of chapter 6, Surveying Methods. So in the last lesson, which was data collection and graphing, we learned all about the process of collecting data and a few different ways to collect data. And in lesson 2, we'll be building off of that in a big topic called surveying methods. So it's learning about different types of methods of surveying. Learning goals for today is understand the sample surveying process, population, individuals, and being able to choose appropriate survey methods to solve related problems. Second, clarify the advantages and limitations for sample surveying and being able to design an appropriate survey plan. Let's get started with our first section, surveying methods. Question 1. New Year's Day is approaching and the class will be holding a New Year's Day party. How would you plan the event? Think. What information do you need to know first when planning this event? How do you receive this information? So I want you to pause for a moment. If you're going to be planning a large event like this, a New Year's party, how would you plan it? So first, just like last time, the first step was to identify the object of the investigation. Of course, and that is your class. And the investigation method you would do would probably be a questionnaire to survey and ask each student questions about what they think should go on New Year's Day. And then probably create the most popular option or build from all those replies and then think about what would make the majority of the student body happy. So right now we're going to learn about something called a census investigation, and then we're going to work on some vocab words. So a comprehensive survey of all objects for a specific purpose is called the census. The total of respondents is called the population. The total of respondents is called the population, and each survey object, notice the word each, that constitutes the whole is called an individual. So here's some discussions. 1. To investigate the heights of your classmates, what would be the population and individual data? 2. When conducting a census of the time spent on housework each week for the whole class, what is the population and individual data? So if you were going to investigate the heights of all your classmates, what would be the data population of the population and the data for each individual? How would you graph that? How would you analyze that? How would you receive that? And how would you work with that? 2. When conducting a census of the time spent on housework each week for the whole class, which is the population, what is the population data and the individual data? So ask yourself, how do you obtain this information? What will you do with this information? And the differences of these informations, how they're different, and how do you get each of the population data and individual data. So here's question 2, and I want you to try to solve this on your own first. If you really don't know, just unpause the video and then we'll work through it together. Question 2. A bulb manufacturer improved a certain process in the production process and produced 500 new bulbs. Now we need to test these 500 new bulbs to see if the service life of the new bulbs is longer than that of the original bulbs. When doing such a test, can we test all of these 500 new bulbs? Why or why not? So let me first explain this question a little bit before you do it on your own. So there's a bulb manufacturer, like one of those light bulbs you would use in a lamp, for example, improve the process of manufacturing the bulbs in the factory. And using that new process, he produced 500 new bulbs. Now we need to test these 500 new bulbs to see if the service life of these new bulbs, say the service life for one bulb is 5 minutes. Geez, that is a really bad bulb, but say the service life is 5 minutes of the original bulb. We need to see and that service life is how long it's going to be lighting up. So we need to see if the service life of these new bulbs is longer than that of the original bulb, because usually the longer the service life it is, the longer you can use it, which is better. So when doing such a test, can we test all 500 new bulbs? Why or why not? Now this really gets to the point we're going to try to make out of this lesson of finding the proper way to obtain this data and answering this question. And notice we just learned about individual and population data. So do you have a way that you can use out of the concepts individual and population data? So there's 500 light bulbs, and there's no way we can test out all of these 500 new bulbs. So what we can do is, here it says the census can collect more comprehensive and accurate data, but we cannot conduct a census on these 500 bulbs. So we just learned about the way of census. So surveying a whole population, each individual in that population is surveyed in a census, and it can collect more comprehensive and accurate data. But we can never conduct a census on all of these 500 bulbs. It's just the amount is simply too big. So, if the number of light bulbs is large, the workload is large, and it is difficult to carry out the information due to the constraints of objective conditions. So, there's too much bulbs, we cannot survey each of them. We cannot test out each of them. So, what we can do is that we can take out a random sample of these bulbs, just randomly say take out 50, 10, then survey those bulbs, and those will be the so-called representatives of these total 500 bulbs because they were randomly selected. And what it also says here is the investigation can be destructive, and not all bulbs are allowed to be investigated. So in this case, we can take a part of the 500 bulbs for investigation. So let's learn the concept. Sample surveying vocab. Taking some individuals from the population for investigation, this kind of investigation is called sample surveying. So sample surveying, is when you take a few individuals from the whole population and take those as the representatives of the whole population, and then this is called sample surveying. Just read its name and you'll get it. You're just surveying a sample, because these so-called representatives are just a sample of the whole population. A part of individuals drawn from the population is called a sample of the population. So here's example 1. In order to complete the following investigations, what kind of investigation method do you think is more appropriate? A census or a sample surveying method? Remember, a sample surveying method is when you take a few individuals from the whole population for investigation. So you're just serving a sample of it. You would probably want to write a quick note of the two definitions quickly on your notepad. Anyway, so let's get back to this problem. The first investigation you have to solve is understanding the average electricity consumption of each household in your community in a certain month. 2. Knowing the number of smokers in a town. 3. The service lives of a batch of light bulbs. So let's go over the answers. Analysis. It can be selected according to the advantages and disadvantages of the census and sample surveying. Which fits better into these circumstances? The answers are for the first one, sample surveying or census. Either could work. And the second and third one are both sample surveying. Let us go through why these are the answers. So 1. Understanding the average electricity consumption of each household in a community in a certain month. Notice how this says average electricity consumption of each household in a community. First, community, you could think of the whole city as just your neighborhood or just your apartment building. You can, no matter how big, for example, for a bigger community, you might want to do sample serving. But for a smaller community, you might want to do census because, well, I mean, it's easier and more accurate if you do census, but it'll be easier if you do use sample serving for a larger population. 2. Knowing the number of smokers in a town, and that is sample serving. So how we can use sample serving in here is say you have a total of about say 500 total population in your community, whatever community, so in town. Then what you do is you take a random, say 50 from these, a random 50, and remember, not just 50 from one single neighborhood, 50 from just randomly 50. Then you're going to, from these 50, count how much people from this smaller sample population of 50, and from the sample population, count out how much of these people smoke. Say, 5 smoke. And since these were randomly chosen, you can get an idea of the percentage of the people from this actual 500 population about how much people from the 500 population smokes. So what you can do is you will multiply the denominator and numerator by 10. So now the bottom is 500 and the top is 50. It tells you from 500 people, 50 people in the community smokes. Now this is just a example. I don't want you actually thinking this, but now let's get on to 3. The service lives of a batch of light bulbs. So you want to compare the service lives and collect data about a batch of light bulbs. Of course, you would do sample serving because a whole batch, that's a lot. You can't literally, in testing these, requires a lot of time. So you probably won't have time for, say, a whole 500 of these. So that would be using sample serving. But of course, if it's a super tiny amount of just 5 light bulbs, you could probably also do census, and that would be more accurate. So now here are some comparisons between data collecting methods. So this is a census method, and this is a sample serving method. Let's first quickly go over what these two methods are. So census is the most accurate data from the whole population. But sample serving is usually from a super huge population. You can't test out the whole population, and you can't investigate the whole population. So you just take a quick random sample of it and then just investigate that sample, and you can assume that it is close to the accurateness of the whole population because, and remember, it has to be randomly selected. So these are some advantages and these are some disadvantages the census and sample serving may have. So let's first look at the census. Collect data by surveying the population, and the survey results are most accurate. So the data you're going to collect from the whole population by using the census method is that the survey results are the most accurate. But the disadvantage that this has is that the workload is large and difficult. There is a lot of people usually in a population that you have to survey, and some surveys are not suitable for the census method. And sample surveying, collecting data through survey samples, the workload is small and easy to carry out, and that is an advantage. It's just through small samples, so the workload is smaller. but the survey results are not as often as accurate as the results obtained from the census, because who knows, maybe the sample isn't random enough. So here's a conclusion. These are the circumstances that would be suitable for census conditions. So relatively not difficult, requires a precise result, and these are the ones suitable for sample surveying. So the population is large and has other restrictions such as time, funding, etc. Choosing appropriate methods. In order to understand the health status of the elderly in your area, how are you going to collect data? The following are the survey results of 3 teams of A, B, and C. Team A. We surveyed 1,000 elderly people in the park, and the number of times they fell ill in a year is shown in the figure. And as you can see, there is a bar chart over here. 1 to 2 times were the most people. 3 to 6 times were not as much, 5 times smaller in fact, and 7 or more times was only 23 people. Team B. We surveyed 100 elderly people in the hospital, and the number of times they fell ill in a year is shown in the figure. And the text you might not see here, but the blue part says 1 to 2 times, the magenta part is 3 to 6 times, and the pale yellow part is 7 plus times. Now, in here, the 7 plus times, why is there such a major difference? Such a major difference in the number of 7 plus times from Team A and the number of 7 plus times in Team B. I wonder why. Team C. We surveyed 10 elderly neighbors. The number of times they fell ill in a year is shown in the table. Number of times ill in number of people. 1 to 2 times is 4 people. 3 to 6 times, 5 people. 7 or more times, 1 person. Now let's do some comparisons. What do you think about, from the different experiments and places these 3 teams did their investigations, where do you think makes the most sense? Well, first, if we're going to discuss this question, let's first think about the major contrast between the results